science spring project on the two-way ANOVA using I analyzed the tooth growth data set. So a little bit of background on the data set that I used. The data set originated from a biological study examining tooth growth in guinea pigs. Well, you see, one day I'm wanting to go into medicine and perhaps into dentistry. So when I came across this data set, I found it particularly fascinating. The independent variables used in the data set included supplement type, otherwise known as sup, or orange juice, designated as OJ, and the dose level of either 0.5, 1, or 2 milligrams. The dependent variable here was tooth length, LEN, which measured the growth of the teeth. So here are a couple of my guiding questions through my research. Does supplement type affect tooth growth? Does average level affect tooth growth? Is there an interaction between supplement type and dose? So let's have a look at my initial data exploration. So I initially loaded the tooth growth dataset and converted the dose variable to a categorical factor for proper ANOVA analysis. There is a roughly balanced distribution of supplement types and dose levels. By looking at the box plots, we see that higher doses generally led to tooth growth, to greater tooth growth. Orange juice appeared to have a stronger effect at lower doses. So you can see here, at lower doses, orange juice had a pretty significant growth, or had a pretty significant impact on growth. But at higher levels, there really wasn't too much difference. So now for the two-way ANOVA. I initially used the Levene's test. Here's my implementation of the Levene's test to check for the homogeneity of variances. The p-value was greater than 0.05, as 0.1484 is greater than 0.05, indicating equal variance and thus ANOVA assumptions could hold. I then used the residuals versus fitted plot to check for equal variance. My QQ plot ensured normality. Let's have a look at my residuals versus fitted. We see a nice scatter, and then my normal QQ plot shows a very linear trend. Both of which check out, and all the assumptions were ultimately verified. So these were my key results. So both supplement type and dose levels significantly affect tooth growth. We can see here in the p-values that supplement was 0.0002, which was also significant because that's less than 0.05. Dose was highly significant as it's basically almost close to 0. And interaction between supplement and dose was also significant as 0.021 is less than 0.05. The interaction term is significant. And higher doses lead to more growth, but orange juice is more effective at lower doses. So now assessing the model fit. I generated a two-case non-additivity plot to check interactions and found a curved or slope pattern suggesting the interaction effects exist. Right here. For confidence interval and effect size, I ran a t-test with confidence level of 0.95, and I found that there was a significant difference in tooth growth between the supplement types. I then calculated the effect size here and found a large effect size indicating meaningful differences, my effect size of negative 0.49. So now what were some of my conclusions? Supplement type and dose significantly impact tooth growth. Higher doses lead to greater tooth length, but orange juice is more effective at lower doses. The significant interaction term suggests that supplement effectiveness depends on dose level. And yes, the assumptions were verified, ensuring the reliability of the model. Why does this matter? Well, understanding how vitamin C is absorbed and the optimal dose for growth is important for dietary recommendations. We can apply this same logic from teeth in guinea pigs to most human bodily functions. This study definitely provides insights into nutrient efficiency, and can potentially guide future medical and nutritional research. Thank you.